Hello people, I hope you all are doing well. Now in this video, we are going to be learning about how to mix the two worlds of WebGL and HTML. And I promise I'm going to make it super easy for you guys. So if you come to this website, you can see a lot of images aligned perfectly. And when you hover over this, you can see some kind of a transition going on. And you must be thinking, how did they do that? And there is a super cool hover wave that follows your mouse around, and there is this magnet effect. So cool. So this is not HTML nor CSS. This is the power of WebGL. Now, how do I know if this is a WebGL or not? So if you go in there and if you search for a canvas element, canvas, yeah, you can see this canvas with the id 3, so probably it's 3js. And if you try hiding the canvas by saying display none, okay, now you can't see the effect. You can see the images but you can see the effect. So what's happening here is we set up a canvas element which is fixed to our screen like this with top 0, left 0, and we put a z index value to the highest. And the next part is mixing the WebGL and HTML. We overlap the WebGL images with the HTML images so that it looks like it is HTML, but it's actually not. Now that's the part where this effect looks super cool. You can't even distinguish if this is a WebGL or HTML. Okay, so let's get started to building this crazy shit. Here, if you take a look at the boilerplate, we have a very basic HTML image and a WebGL plane. Now, in the index HTML, I have set up a custom attribute known as the data WebGL media for each of the image that I want this WebGL to take over. Now, you can use the class and ID, but I find this more readable than classes and ID, but you can do whatever you want. Now in this JavaScript, I have set the width and height in the sizes. I have put this width and height in the sizes instead of normally saying it like this. And I'll tell you why we're gonna do this after a while. So very basic, I'm just updating the sizes and width and height. Okay, now let's get started with this mixing of WebGL and HTML. So the main part in mixing the dimensions of WebGL and HTML comes in the camera part. So normally we have a plane geometry with a very small value, width and height 0.2 0.2, and we can already see it. Now let's say I'm giving it 1.2. It's pretty big, right? Now I don't want this when I'm giving such a small value as 1, I don't want it to be this big. But imagine if you are giving a width value of 1.2 pixels in CSS, you won't be able to even see it, right? Now I want this values to be exactly same as the pixel values in the web. Now what I mean by that, I have explained this already in one of my videos, so I'll just explain it once more. So one unit in 3js, we say these are units, right? So one unit in 3 is equal to, let's say, a few hundred pixels, right? Let's assume it's a few hundred pixels. I don't know the exact values, but let's assume it's a few hundred pixels. And what I want is, I want the same one unit to be equal to 1 pixel. 1 pixel in the web. 1 unit in 3js equal to 1 pixel in the web. So if I'm taking a value like 1000 units in WebGL in my 3js, it should return me a value of 1000 pixels in the web. Okay, I think you are starting to understand what we're gonna do. So to make that work, we have to tweak the camera properties. And the first property we're gonna change is this FOV. So everything here is going to be in the values of 50. So I'm setting this to 500, right? And I'll tell you why I'm giving this 500. And I have this camera position, and I'm gonna be updating the FOV once again. We're gonna see a complicated formula here, so don't be scared by it. Exactly. And if you check, we have this 500 and this 500 same. So make sure this 500 and the value here, maybe this would be 1 if you are trying to use GPT or Copilot. So make sure to set this to 500 and this camera position Z to 500 and this FOV to 500. All right. And if you check, you can see nothing basically. And one more thing you have to change is you have to set this frustum, because when we're moving the camera too far away, we will be clipping it. You won't be able to see it unless we give it like 100 and 1,000, a big value, both big values. Now if you look closely, you can see a point pixel colored, and that's our plane. After you update the camera, always remember to update the projection metrics. Otherwise it will look weird. We're always updating the projection metrics, right, when we're resizing. Likewise, we need to update the projection metrics here. Otherwise it will look stretched. It won't have the exact pixelated value, right? That's it. Now that's it for mixing the two dimensions, the WebGL dimension and the HTML dimension. Now everything is in pixels and I'll show you. Now instead of giving 1.2, let's say I'm giving 100. Okay, I'm not able to see anything. Why? Camera.projection metrics is not a function. Update projection metrics, my bad. I'm gonna update this projection metrics. Right now we can see the plane, and even if I'm giving the 100 value, it's pretty small, right? It should be exactly 100 pixel by 100 pixel. Now in the next part we're gonna mix this dimensions of this plane, and we're gonna add each plane for the 6 images. So there will be one mesh for this image, one mesh for this image, this one and this one. Okay, but how are we gonna do that? And I'll give you a summary of what we're gonna do right now. So I have a custom attribute for this images, right, which is the data WebGL media, and I'm going to run a loop on these images. I'm going to save these images in an array, and I'm going to loop through them, and I'm going to create a mesh for each of these, right, with its texture on it. Okay, and then we're gonna position it such that it will be in the same position as this HTML image. Pretty cool. Okay, let's get started with that. Now I'm going to create a function to save our WebGL part, the mixing of WebGL and HTML part. So let's say function set media store. Let's say set media size, whatever that is. And I'm just going to call it real quick because I'm gonna forget it otherwise. Okay, we call the function. Now we need to create a mesh for each of these images. So I'm going to save these images in an array like I said before. Document dot query selector all. We're gonna select all of the images, and we're gonna select it by the attribute, which is the data WebGL media. Now let's check if it's working. I'm gonna console it. We have a node list of 6 images, right? I'm going to map through this. You can either use a for each or a map, but I'm going to use for each. I'm going to use map for this, but you can use for each. Anything works, both gets the job done. I'm going to map this. I'm going to get the actual image and the index of the image. Okay, and I'm going to create a common geometry for each of these images, so it will be more performant. I don't have to create each geometry for each of these images, so I'm just going to create a common geometry, and let's call it image geo, which is equal to, make sure to put these values as 1, and I'm leaving it as 10 10 because I'm going to make the wave effect, and it's going to be working on the vertex shader, so it needs to be subdivided into some 10 by 10, 100 by 100, whatever you want, but let's leave it at 10 by 10 right now. I'm going to create a material for each of the images. Now I'm not creating same material for each of the images, because if I do that I won't be able to get different images on each of the plane. So what I'm going to do is const image material is equal to new 3 dot 3 dot shader material. It's not necessary to use a shader material, but in our case I'm going to make the wave effect, so I need the custom shader material. So I'm just going to write the very basic. Right, now we have the vertex shader, fragment shader. I have already imported it, and just make sure to remove this, accidentally came. And we have the time and the U texture. Now in the U texture we are loading the texture of this image by saying we have this image value, right? Now we can get the source, this URL part of this image, by saying image.src, and this handles the texture part. That's it. Now I'm creating a mesh, image mesh. Let's just leave it as mesh right now. Okay, now I'm going to add it to the scene. Okay, we have nothing. It's because the width and the height is at 1 1. Now what I'm going to do is I'm going to position these images, and I'm going to scale these images to this width and the height of the actual images in the array. So if I want to access the dimensions of the image, I need to use the get bounding client rect. So I can say width, height, top, left from image.getBounding client rect. Now if you don't know what this is basically the same as writing const width is equal to image.getBounding client rect dot width. This is the same as this, but I like to use this because it's much easier and much convenient for me. Okay, now why I didn't give the actual size of the image here, it's because when you're trying to make this responsive, you can't update the values of the plane geometry, but on the other hand you can always update the scale. You can always update the scale of the mesh, and we're going to set it to the actual width, the actual height, and leave the z value to 1. Okay, now we are not seeing anything. Let's check why. Images.map is not a function. Oh, my bad. So make sure to put this in an array. So I'm going to create an array of all of these images. Right, now we have it. Now we have a mesh which is almost the exactly same size as these planes, right? These images, right? And I want to position this. Okay, but I have the top and left value. Cool. Now let's adjust the position x. The position x value. So let's leave it at left. Let's check what we have. Okay. Now if you look closely, the WebGL images are literally at the center and the right. It crosses the center and the right. So if I want to make this image come here around the left, which is its actual position. Okay, this VUV might be confusing for you. I'm going to move it to the texture. Okay, now if you see, this cat image is not here, but it's rather on the left side, but it went halfway to the right, exactly the halfway to the right. So I'm going to minus the width, half of the width of this whole window. So what I mean by that is I'm going to minus the window dot inner width. by 2, and let's see what we have. Okay, now we have this image here, but a little more is left. Look closely and you can see this image is halfway to this actual size of the image. So if I'm adding the half width of this actual image to the position X, I should be able to see this in the actual position. So I'm saying width by 2. This width is coming from the get bounding client. There you have it. Now we mix the X direction. As simple as that. Now we need to mix the Y direction, right? So for the Y direction is the same. It's the same but small changes. In 3JS, the Y direction is flipped. If the value in the HTML is Y, it is minus Y in WebGL in 3JS. So instead of saying top, I'm going to say minus top. This formula is going to be still the same, but it's going to be inverted. So instead of plus, I'm giving minus, and instead of minus, I'm giving plus. So instead of width, this is the position Y, right? So I'm giving it sizes.height by 2, and instead of adding the width, I'm subtracting the width. Now if you check, we should be able to see this, and now if we subtract the height, we should be able to see it in the correct position. Height by 2. Okay, now you can't see the image. Why? I'm just removing this other mesh for a while. You can't see this, right? Now you can see the WebGL images. Why? And I'll show you why. What I'm gonna do is I'm gonna set the opacity to 0. So you must be wondering, nothing changed. No, it changed. If you resize, you can see the WebGL images. If it was the HTML image, it should have been resized. If you see the HTML is way off from this image. So if I refresh, that's cool. Now we mix the WebGL and HTML, but when we resize, the whole thing breaks. So what we're gonna do is we're gonna update the position and the scale as we resize. What do you mean by that? So I'm going to update the values here on the add event listener with resize. But how can I access this position X, this mesh and this material here? You obviously can't, because the scope of this variable is only inside this loop. Cool. So I'm going to create another variable. Let's say WebGL images, and it's an empty array. Now I'm going to say WebGL images equal to images.map. So I'm saving this function's values into this variable. So if I want to access one of these properties, I just have to return it. What do I have to return? The first thing we need, it is a mesh. So you have to give it like this. The first one is the variable name and the actual thing you want to access, which is the mesh. Since these two variables name are same, we can just leave it as it is, right? Like this. And the material, we need the material to update the uniform values. And let's say image material. And one more thing, we need to access the image. Why? Because we need to get this image.getBounding client rect here in the resize. Okay, pretty cool. Now if I come here and say I'm going to use for each loop this time, because I'm going to teach you how to do it with for each as well. It's the same thing, just instead of map it will become for each. WebGL images dot for each, and I'm going to access the object. Let's give it the object and the index. Okay, cool. Now if I want to access this mesh material and object, everything is saved inside this object. So if I want to access the mesh, I can say object.mesh, right? So first things first, I need to reinitialize the image.getBounding client rect. So I'm going to come here, copy the same thing, oops, here, right? But there is no image defined. So in order to access this image we returned, I'm going to say object.image. Now we have the get bounding client direct values. And the next part is to update the position and the scale. So I'm just going to copy the same thing. We don't have to write this again. And we don't have the mesh yet. So I'm going to say object dot mesh, because this mesh is inside this object. So if I want to access it, I want to set the dot operator and the mesh. Very cool. Okay, now let's check what happened. So make sure to update the camera projection metrics. Like if you're putting this on the top, it won't work, because we update the projection metrics after we do the calculations, right? So let's see now. Okay, the WebGL didn't break. Holy shit, it looks exactly like the HTML images, right? Now that's the it is even responsive. If you set the CSS responsive, this WebGL will automatically become responsive. But there is one more problem here, which is the scroll. If I scroll, the HTML scrolls but the WebGL doesn't. It's because we haven't passed the scroll values to the y direction of these images. I'll give you guys a task. I'll tell you how to make this scroll work, but you guys have to do it. It's very simple, but I'm giving you a task. Alright, so I'll tell you at the end of this video. So basically we have everything. Now how you must be joking. This is not you. If you can't believe this is the WebGL, I'll show you. I hope this convinces you, because we have the VUVs and it's shrinking perfectly, like perfectly. Cool, right? Let's put back the texture and I'll tell you the scroll part. So if I'm adding the window scroll y in the y direction, this mesh position y, we will have stuttering with this WebGL image. So to compensate for that, we're going to use a custom scroll like Linus scroll, so you can get the values of scroll with Linus, right? And I'm going to pass that scroll value to this mesh position y. I'm just going to add it. Okay, it's very simple, but I'm leaving it to you guys. And make sure to update that scroll value in the animate function, otherwise we will have the stuttering effect again. So to create a smooth scrolling in the WebGL, you just have to write the scroll values, update the scroll values in this animate function, right? And that's pretty much about this mixing of WebGL and HTML. Everything works fine. If I'm doing some kind of a crazy shit, like let's say vec3 position, let's see position, I'm just saying some random value plus equal to some random, and I'm saying position. Okay, I haven't imported the time yet. Uniform float time, and I haven't updated the time value yet. So if I want to update the uniform of this, how do I do that? So I have to run this WebGL images again. As simple as that, because I have already passed the material, and if I want to access the uniforms of the material, I just have to say object.material.uniforms, then that uniform name, then the value. That's it. Now this should be able to see something, but we are not able to see something. Yeah, let's go. So freaking cool. We have the wave effect. It is responsive even in mobiles. Isn't that so cool? When I started learning this, it wasn't this easy for me. I learned it from an awards course which is known as Merging WebGL and HTML by Yuri Atoik. Again, he's my favorite person. So when he taught me this, it was so complicated. He was teaching using class and constructors, and I was not familiar with that. So recently I started making this on my own. I was just trying it trying things out, and I made it in a very simple way. Just look at the amount of code. There's barely anything. Let's say around like 10-20 lines of code, and we already have the mixing of WebGL and HTML. Crazy shit, right? And in the next video, if we get enough reach for this video, if we get enough support for this video, I'm going to make this wave effect. It will follow our mouse around. We'll have this scaling effect. We will have this magnet effect. All right, sounds pretty cool, right? There you have it. And I'll show you one more thing. Let's, instead of position X, what if I do, okay, let's not do that. And instead of this, I could do this. Exactly. And maybe I could do it same for the X as well. Let's see what we have. Wow, that's what I'm talking about. I think it's too much, the intensity. Let's say 5. Now we have a subtle effect. That is beautiful. And I hope you guys love this video, because I love this video because it makes me so excited to see these shader effects right on top of the HTML images. So cool, man. And yeah, I hope you guys loved it. Thank you so much for watching. And I'm trying to improve my teaching skills day by day. I enjoy teaching a lot. So if you guys have any suggestions, then make sure to drop a comment. Yeah, thank you so much for watching. Bye bye. See you on the next one.